speed of DC motor according to the rise in temperature. And for this easy project, you will need LM35 temperature sensor, Arduino board, L29 3D IC or any other motor driver IC, DC motor with a 12 volt power supply and a breadboard. This video is sponsored by GLC PCB, which provides the prototype PCBs for all type of electronics project. They design PCBs within 24 hours of ordering and deliver PCBs to your doorstep quickly due to their fast shipping service. It is worth mentioning that they provide high quality PCBs for just $2. So just upload your Gerber file and get a high quality PCB for your project. Let's take a look at the pinouts of LM35. Plus VCC and ground provides power to the IC, whereas V output gives the output voltage corresponding to temperature. L29 3D is a 16-pin motor driver IC used to drive the DC motors in either direction, and up to 2 motors can be driven using single L29 3D IC. To make things easier, L29 3D modules are available in market, but if you are a beginner, I will suggest you to get familiar with IC first and then move on to the module version. Now you must be thinking, what is the need of a motor driver IC here? Well, it depends on the type of your DC motor. If its voltage and current ratings are high, then you must use a motor driver because Arduino is unable to provide such high current to DC motor. Here is the pinout of L29 3D IC having DIP package with 16 pins. I'll try to explain each pin to you one by one. Pin number 3 and 6 are output 1 and output 2 respectively and are directly connected to the terminals of motor 1. Similarly, output 3 and output 4 to the terminals of second motor. But since we need only one motor for this project, we will leave output 3 and output 4 as it is. Pin number 2 is IN1 or input 1. This pin is connected to the digital output pin of Arduino to control output 1. Similarly, IN2, IN3 and IN4 for output 2, output 3 and output 4 respectively. Pin number 1 is enable pin 1, which enables both output 1 and output 2 either on or off. That is, in order to use these pins as output, enable pin must be set high, as mentioned here, controlled by EN1. Similarly, pin number 9, that is enable 2 for output 3 and output 4. Please note that if enable pin 1 is grounded, then IN1 and IN2 will be of no use to control output 1 and output 2 respectively. Pin number 4, 5, 13 and 12 are ground pins and should be connected to the ground of Arduino. Pin number 8 is plus V motor. This pin is connected to the external power supply to directly power the motor. In our case, this pin goes to the V-in pin of Arduino since we are going to use external 12 volt adapter to power Arduino. Pin number 16 is plus V. This pin is connected to 5 volt pin of Arduino, which provides power to the IC. So we have covered each pin of the IC. But wait, there's a cool feature of enable pin I haven't mentioned yet. Enable pin can also control the motor speed according to the PWM voltage applied to it. For example, if 5 volts is applied at EN1, then motor will run at its maximum speed. If 0 volts is applied at EN1, then motor will not run. And if 2.5 volts is applied, motor will rotate slower than the 5 volt case. Thus, if EN1 is connected to the PWM pin of Arduino, we can easily control the speed of the motor. And we are going to use this function of L29 3D in our project. These are the circuit connections for the same. VCC and ground pin of LM35 goes to 5 volt and ground pin of Arduino respectively, whereas V output pin goes to the analog pin A0. For L29 3D IC, pin number 16 is given 5 volt, pin number 4, 5, 12 and 13 connects to ground. Pin number 3 and 6 are connected to the output terminal of the DC motor. Pin number 2 and 7 goes to pin number 8 and 7 of Arduino. Pin number 8 of IC goes to V-in pin of Arduino for 12 volts, and last but most important pin number 1, which is enable 1, goes to the PWM pin 10 of Arduino Uno. And here is the program you need to write for this project. First of all, you need to measure the room temperature, and then according to that temperature, you have to set the temperature limits between which the fan should work. So I have already measured the room temperature, which is around 30 degrees Celsius right now. So I'll set temperature limit between 31 to 40. Now first you have to set pin 8, 9 and 10 as output pins. Then store the analog value received from analog pin A0 to float variable V output. Then we use this formula to get temperature in degrees Celsius. Pin number 8 and 9 controls the motor state, whereas PWM pin 10 determines the speed of the motor. And we need PWM values corresponding to different temperature, which we can then give to enable pin of Arduino 3D. This way it will be able to adjust motor speed according to the defined temperature. So to get PWM values corresponding to different temperature, we are going to use map function. The work of this function is to convert the temperature values between 31 to 40 degrees Celsius into corresponding values between 100 to 255. Now you must be thinking why I have chosen 31 and 100 here instead of 0. Well, because first of all, fan should start running only when temperature reaches 31, and when that happens, there should be a minimum of 100 PWM value at enable pin. And as temperature increases from 31 to 40, PWM value at enable pin increases from 100 to 255. That is, at 40 degrees Celsius, fan will be running at maximum speed. And after that, we have to define the temperature conditions. So if temperature is greater than or equals to 31, pin 8 and 9 should be high and low respectively. Also, the pin 10, which is PWM pin, should output PWM voltage corresponding to the temperature. Let's suppose temperature reaches 31, map function will convert this to a PWM value which is 100. This value of voltage will then be given to enable pin 1 by pin 10, which determines the speed of the fan. And as temperature rises, map function will keep increasing the PWM value, which in turn increases the speed of motor. And else, in any other case, or when temperature is less than 31 degrees Celsius, pin 10 should give 0 voltage to enable pin 1, thus disabling the output 1 and output 2 connected to the motor terminal, and hence when temperature will be less than 31 degrees Celsius, fan will not run. So guys, that's all we need to write in this code. I know I took a lot of time to explain the code, but believe me, it's important for you to understand everything that is happening here if you are a beginner. Now let's upload the code to Arduino and open serial monitor. Here you can see the room temperature, which is around 30 degrees Celsius, and that's why I chose 31 degrees Celsius and not 30 in the code, so that the fan does not start and stops randomly. And these are the corresponding PWM value, which obviously is less than 100. Let's bring hot iron close to the temperature sensor to see how temperature and PWM value changes. Here at 31 degrees Celsius, you can see PWM value is exactly 100 as we specified in the code, and for 40 degrees Celsius, it's 255. Now since maximum PWM value the PWM pin can provide is 255, values more than that provides same voltage at output, and hence no change in speed of the motor. Guys, you can clearly see there is something wrong here. Why? Because the speed fluctuates too much. You can clearly observe that. Now there are two reasons for that. First, temperature is changing too frequently, 30 degree to 40 within seconds, and then 40 to 30 within seconds, because I'm using hot iron, and this causes speed fluctuations. So in real case, when temperature changes very slowly, there would be very little speed fluctuations at a particular temperature. Now second reason is that this speed control system is an open loop control system, or in simple terms, direct control. So there is no feedback kind of thing which would make control more stable. But we can easily solve our problem by using PID controller here. So in the next part of this tutorial, we will upgrade this project to a PID temperature controlled fan. I hope you like this video. Don't forget to let me know your thoughts on this. Now I'll see you next time. Bye bye.